Welcome to the second session of the topic, the periodic table. So in the previous video, we looked at recap of periodic table. We also looked at periodic trends, and we looked at some group properties where we were visiting some special groups, and we did visit one group, and that was group 1. In this video, we're going to visit group 2. We see some properties of group 2, and after that we are also going to take a look at group 7. In the next video, we'll look at group O or group 8 and also transition methods. Let's get started. So just a reminder, the periodic table is just a chart of elements placed according to the order of increasing atomic number, and this is the periodic table. So in the previous videos, we looked at this group, which is group 1. In this video, we're going to take a look at group 2. So the properties of group 2 elements and group 1 elements, especially the physical properties, are close. They're not that different, and even the chemical behavior is not that different. The main difference is these group 2 elements have 2 electrons in the outermost shell. Well, these ones have 1 electron in the outermost shell. So that's the main difference, but otherwise the behavior is nearly the same, as you're going to see. So the group 2 elements are also known as alkali earth metals. They are called alkali earth metals because they react with water to form alkaline solutions and are usually found in the earth. So the name is made of 2 parts, alkali and earth. So alkali is because they react with water to form solutions which are called alkaline solutions. Then the word earth is because they are found in the earth. So if you remember, group 1 metals are very reactive, and they're usually found in form of compounds because they can't just be without combining with other elements. The same is true for group 2. They are also very reactive, but not as reactive as group 1 elements. Remember the periodic trends. Reactivity decreases as you move from left to right in the periods. So as you move from group 1 to group 2 are less reactive as compared to group 1, but group 2 are reactive as compared to other elements on the periodic table. With that being said, they are found on the earth. That's like where they're naturally found, because they are very reactive, so they react with whatever they come into contact with. So that's why the name alkali earth metals. So just an emphasis, occurrence of group 2 elements. So group 2 elements do not occur naturally as free elements because they are very active, which is what I'm from saying. So let's take a look at some physical properties of group 2 elements. The first is they have a dull appearance. Second is they are shiny and silvery. So let's take a look at an example of a group 2 element. We're going to use calcium. So if you look at calcium here, or calcium, it's shiny and silvery, but again it has that dull appearance. So this is the one of the physical properties of group 2 elements. They are good conductors of heat and electricity. Sorry, the picture yeah, the picture is hiding the words here, but it's heat and electricity. They have low densities. What do they mean? They have low densities. It means most of them can float on water. They are malleable. What does it mean to be malleable? If something is malleable, then when you hammer it, it can easily bend into another shape. So if something is malleable, can change its shape just by hammering it. So group 2 elements are very malleable. They are also ductile. So to be ductile is to have the ability to be drawn out in a thin wire. So a group 2 element, you can compress them such that you end up forming a thin wire using whatever you can use to compress them. Yes, but in short, what I'm trying to say is group 2 elements, you can make wires, thin wires, using group 2 elements, and that's what the word ductile means. So we go to chemical properties of group 2 elements. It's supposed to be group 2 elements here. So one, they have two electrons. They have two electrons in their outermost shells. Number two, they lose their two electrons in their outermost shells to form ions with positive 2 charge. So these two chemical properties, we already know them. Three, they are relatively reactive but not as reactive as group 1 metals. 4, they react with oxygen to form basic oxides. Just like group 1 metals, they also react with oxygen to form basic oxides. They form ionic bonds when they react with non-metals, just like group 1 elements, which also form ionic bonds, especially when they react with group 7 elements. So now there's a trend in chemical reactivity of group 2 elements, and the trend is the reactivity of group 2 elements increases as you go down the group. So what does it means? If you go to group 2, the reactivity increases as you go down, just like in group 1. So in group 1, we noticed that as you go down, the elements become more reactive, and we concluded that francium was more reactive and lithium was less reactive among the group 1 elements. So even for group 2, it's the same. The reactivity increases as you go down, making radium the most reactive and beryllium the least reactive. So that's everything about group 2 elements. Now let's go to group 7 elements, which are kind of different and they've got kind of opposite properties as compared to group 1 and group 2, because these are non-metals. So let's get started on group 7 elements. So these ones are called halogens, and they are called halogens because they react with group 1 elements to form salts. In fact, the word halogen means salt former, or something that makes salt. So when group 7 elements react with group 1 elements, they make salts. So where group 7 elements found? Group 7 elements do not occur naturally in a free state, just like group 1 and group 2. Instead, they exist as diatomic molecules. So group 1 and group 2, they just exist in compounds. Group 7 elements exist in terms of in form of molecules. So what diatomic means is they exist as molecules that are made of two atoms that are combined. For example, chlorine. So chlorine naturally it is found as two chlorine atoms which are chemically combined in a covalent bond. So that's what diatomic means. So whenever you hear of diatomic molecules, just know that usually it's group 7 elements. So here are some physical properties of group 7 elements. They exist as colored non-metallic elements, so they have colors. The easiest way to remember this is chlorine. If you have ever seen chlorine, it has a certain color. Okay, so it's a good example you can use to remember. So here are the colors. So the first one is fluorine. Fluorine, the color is pale yellow. Then we have chlorine, which is yellowish green. Then we have bromine, which is reddish brown, and we have iodine, which is black. One thing you can notice is as you go down, because the way I've written them here is the way they are arranged on the periodic table. So as you go down the group, they become darker. So the one on top, fluorine, it's pale yellow. Then as you go down, the color keeps on getting darker. So it's it's a thing you can use as a memory aid. So as you go down the group, the color becomes a little bit dark. So fluorine, pale yellow, yellowish green, reddish brown, till black. Then the second physical property is they show a gradual change in their physical states at room temperature and pressure. So as you go down the group, this is what is observed. A mistake here, not color, it is the physical state. So fluorine is a gas, chlorine is also a gas, bromine, it's a liquid, iodine, it's a solid. So as you go down the group, they become more solid, or the particles that makes up the elements become closely packed. As you remember, solid particles are closely packed as compared to liquid, as compared to gases. So this is a trend that is observed in the physical state of group 7 elements. Their melting and boiling points increases as you go down the group. So this should also be intuitive. How so? The melting point and boiling point increases as you go down the group. But and we are from seeing that they become more solid as you go down, and we expect solid to have a higher melting and boiling point as compared to liquids. We also expect liquids to have a higher melting and boiling points as compared to gases. So as you go down the group, they change from gas, liquid to solid, and also the melting and boiling points increases as you go down the group. Their densities increases as you go down the group. So this also should be intuitive. How so? Because they become more solid, we expect them to become heavier. So their densities increases as you go down the group. Their compounds can either be ionic or covalent. So when they react with metals, then their compounds are ionic, and when they react with non-metals, their compounds are covalent. So here is a chemical trend in the reactivity of group 7 elements. So unlike group 1 and group 2, the reactivity of group 7 elements increases as you go up the group. So this is opposite. As you go up the group, they become more reactive, meaning that the most reactive is fluorine and the least reactive is astatine. So that's the trend in the reactivity series of group 7 elements. Let's take a look at some chemical properties of group 7 elements. First, they all have 7 electrons in their outer shells and hence have similar chemical properties. 2, they gain a single electron to form ions with -1 charge. This we know. They are oxidizing agent because they accept or gain electrons. We're going to study oxidizing agents more, but for now you can take it as any element that has a tendency of losing an electron is a reducing agent, and any element that has a tendency of donating or I mean of accepting or gaining an electron is an oxidizing agent. So most nonmetals are oxidizing agents and most metals are reducing agents. They react with group 1 element to form salts. This we discussed when we were talking about group 1 elements. 5, they displace each other in a chemical reaction involving their halide ions. So halide are just ions of halogen. So group 7 ions that are formed from group 7 elements are called halides. So they are funny. They do what is called a displacement reaction. So in that displacement reaction, then the more reactive halogen will displace the less reactive halogen from its aqueous salt solution. So we're going to take a look at some examples of reactions so that you understand these displacement reactions. So in short, a displacement reaction is just a reaction in which one ion takes the place of another in a compound. So let's take a look at these reactions here. So start with this one. So we have a salt here, which is an aqueous solution. In this salt, we have chlorine and we've got sodium. So when this aqueous salt solution reacts with fluorine, if fluorine is more reactive than chlorine, then this chlorine is going to be removed. Fluorine is going to take the place of chlorine. Okay, so fluorine is going to act like a big boss and it's going to chase away chlorine. And remember, the reactivity series increases as you go up on the group 7 elements. So fluorine is definitely more reactive than chlorine. So when they react, fluorine is going to take the place of chlorine, and we're going to have sodium and fluorine here, and chlorine is going to come out here because it has been chased. So this is an example of a displacement reaction. Another reaction is this one where I've got sodium bromide reacting with chlorine. Again here, chlorine is more reactive than bromine, so chlorine is going to take the place of bromine, and we're going to have sodium chloride and bromine gas coming out here. Then another situation is where we have potassium iodide reacting with bromine. Again, bromine is more reactive than iodine, so bromine is going to take the place of iodine, and we're going to have this, and iodine is going to be removed here. Then an interesting one is this one of sodium chloride and bromine. So bromine wants to take the place of chlorine here. However, bromine is less reactive, so it cannot take the place of chlorine, so nothing is going to happen. So these are examples of displacement reactions. So what are some uses of group 7 elements? First, fluorine is used in fluoride toothpaste to help prevent tooth decay. So Colgate, as Colgate, our toothpaste, our Zambian toothpaste, Colgate as fluoride, as fluorine, which is used to prevent tooth decay. Number two, chlorine is used to sterilize drinking water because it kills harmful microorganisms. So we know how chlorine is very useful, especially in those areas where they get water direct from wells. So there, they need chlorine to make sure that harmful microorganisms are dealt with. Iodine is used as an additive in table salt to prevent goiter in human beings. So there is that disease where there is a growth on the neck called goiter. So that goiter, for it to be prevented, you need iodine in your salt. So what are some of the harmful effects of group 7 elements? So the harmful effects of group 7 elements, the harmful effects actually is just maybe one. Compounds of group 7 elements are known to be responsible for the depletion of the ozone layer. So the amount of heat that comes from the sun has to be prevented, or some of it has to be absorbed before it reaches the earth. So there's a layer that in the atmosphere that protects the earth from all the heat or the rays that comes from the sun. That layer is called the ozone layer. So when you keep on using these group 7 elements, you burn them, when their compounds go up there, they can go and react with the ozone layer. So the ozone layer is made of a compound called ozone, which is just an allotrope of oxygen. So oxygen has got an allotrope called ozone. The normal oxygen gas is written as O2, but the ozone is O3. Okay, so that ozone, which is just oxygen, of course, is going to react with the group 7 elements, and it's going to be used up. Once it is used up, it means the atmosphere or the upper surface that covers the earth is going to be depleted. When it's depleted, it means the intense rays, or the intense rays from the sun is going to reach us, and we might experience disastrous effects. So group 7 elements are very dangerous. That's how to use them. They have to be regulated. In short, these compounds end up depleting the ozone layer. So this marks the end of this topic. Actually, I'm a bit tired today. Yes, I have been teaching the whole day. It's not actually the end of the topic. This marks the end of part 2 of this topic. So there's part 3, which is going to be very short. It's going to deal with group O elements and transition methods. Happy solving.